Hello. Okay, welcome back. Okay, we've got ourselves a new problem that I want to solve today. What I've done is I've recreated sort of a miniature version of the world routing exercise that I gave you a couple of weeks ago. I didn't include everything just because I don't have the files here. Otherwise, it would certainly apply to that. In fact, even more so. Okay, so you see what I've got here. I don't even have everything configured because the intention here today isn't to get this to work. It's simply to explain something. Okay, so over here on the left-hand side, I've got some company. They've got a switch with a bunch of computers and, of course, a router. And on the right-hand side, we've got a bunch of computers with a switch and a router. And in the middle, we've got basically the internet, which is going on, and I've represented it now with just a couple of routers in the middle, but of course, in reality, there would be a whole pile of these things. Okay, so here's the problem that I want to point out today. These individual connections between the company's router and the first router, and between the router and the other company, and of course all the router links in between. Okay, so you notice what I've done. I've done the same thing as what I suggested you do. I've used all these numbers that start with 200. Okay, again, they could have been any other number. I just happen to pick these things. But I've got a bit of a problem now that I want to point out. Okay, so I know that we can make this work because, well, we've gone through and we made the thing work. But what I want to do is I want to pick these two values right here, 200.1.1.1. Okay, slash 24 and 200.1.1.2 slash 24. And of course, we know from our previous lessons that this happens to be a Class C network with a subnet mask. So each one was 255.255.255.0. And just to remind you where those numbers come from, because it's slash 24, if you write this out in binary, it happens to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, and everything else is zeros. Okay, so that's what the slash 24 means. It means that there's 24 ones in the network mask. So in other words, it means that the network that I'm using here is the 200.1.1 network. In this particular link, I'm using the 200.1.2 network, and in this one, I'm using the 200.1.3 network. Now, here's the problem that I've got with this configuration. If you remember, this is also a valid number. Okay, so is 200.1.1.4, and this continues all the way up to 200.1.1.254. But of course, 255 is that funny broadcast address, and of course, the other one that starts at the very beginning is the network name itself. Okay, so this is fine, except take a look. I've got an available 254 different computers that I could put onto this network, but how many am I actually using? Well, I'm only using this one down here, and I'm using this one here. In fact, there's absolutely no chance for anything else. Now, I suppose what you could do is you could put this into a switch and have some other computers, but really the only thing that we want is just the router connected at one end to the other end. So what about the 0.3, the 0.4, the 0.5, the 0.6, the 0.100, the 0.152, the 0.200, and the 0.254? Well, they're all going on waste. There's absolutely no possible way for me to use these things, and that's really sort of unfortunate because it's an awful lot of addresses that we simply cannot use. So in fact, you see what I've done is I've lost basically 252 possible computer addresses in here, another 252 in here, and another 252 in here. They can never be used because I'm just using them to connect one router to another router. Okay, so here's what I want to do. I want to start by changing up some stuff to give you something to think about. All right, so rather than talking about the number 200.1.1.1 slash 24, I want to change things up and I want to write slash 28. And what would this mean? Okay, well, first of all, the slash 28 means that the network mask is a little bit different. Okay, so the network mask or the network submask. Okay, well, what this is going to be, this is going to be 28 ones. Okay, well, let's count them out. 1, 2, 3, 4, 5, 6, 7, 8. 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, and 29, 30, 31, 32. There we go. That's actually what the network mask would look like in this case. Okay, well, maybe in decimal it might be a little bit easier to understand. Okay, 255, 255, 255. So what is this? Okay, well, if you can't read it off directly, well, let's just come over here and make up a binary number 11110000. That's going to be the network mask 240. Okay, so now, if you remember, the stuff that we had done before when we're talking about network classes, it was always groups of 8 that happen to represent the network. Okay, now let me go back and write out this number 200,111 in binary. Okay, all right, so let's do the same thing again. Okay, so 200 is the number. In binary, it's 11001000. Okay, that's the numbers right here. Point 000000001, 000000001, and 000000001. Okay, that's the actual IP address in binary. Okay, now let's go back and let's start to look at the network mask. Now, according to this network mask, if I'm talking about a /28, it means that this is part of the network, this is part of the network, this is part of the network, and 1, 2, 3, 4, that's part of the network, but this part right here is actually the host. Okay, so that's doing exactly the same thing as we did last time, except that the split point between the network number and the host was not exactly at this dot. It seems to be like halfway between. Okay, so what does this mean? Okay, well, back once again. What is the network? Okay, well, the network then would be this number right here. So let me copy and paste this. Okay, and of course we don't know what these things are, but the network number, of course, is a bunch of zeros. Okay, and now the host. I'm sorry, get this over here. So now what are the host values? Well, remember the host now only consists of 4 bits, which means that I could have the host number 0000, 0001, 0010, 0011, 0010, etc., all the way up to 1100. So I'll leave some dots in here to point out that we've got it. 1110, 1111. Okay, so we've got a bunch of possible hosts in here. How many hosts are there total? Well, okay, there are 16 of them. Okay, there are 16 possible values. But remember, just like last time, a host that happens to be all zeros, this means the network name. And a host that happens to be all ones, well, that's called the broadcast address. Okay, so that means how many hosts do I have in total? Well, I'll have 14 possible values. Okay, so there are 14 possible values if we ignore this thing called a network name and the broadcast address. So in other words, if we were to go back and start writing out this 200.1.1 network, this would be one of the numbers. Okay, so that would be all of these values with a bunch of zeros. Okay, in fact, here's what we're going to do. Let's write it out in binary. Okay, so this is going to be one of my numbers. So we'll write it out in binary first, and then we'll write in the decimal equivalent. Okay, so that's one of the numbers. Well, let's keep going. What about the next number? Okay, so sorry, that needs to be a 1. Well, we also have this number right here. Well, that's the number 0.2, etc., etc., etc. This number right here is going to be my next value, so let's copy this one, or not the next one, but the final one. The biggest number looks like 0, 1. I did have the right number, 1110. Okay, and what does this network look like? This is 1.1. Okay, well, that's the number 14. Okay, and then finally, since we're here, let's take this, and this number right here, well, this is number 15, but guess what? This is known as the broadcast address because all of these values happen to be set up with 1s for the host. Okay, and of course, the 4 zeros at the beginning will end up being the network number. Okay, so now, what have we managed to do so far? Well, this looks like we've managed to be able to restrict things quite a bit. But here's what I'm going to do that's going to now be very, very different. Let me take the number that looks like kind of like this. So I'll start it in binary, and let me put this number out here. Okay, so there we go. That happens to be a number, which, by the way, is 200.1.1. Well, that looks like the number 17. But remember that if this was a slash 28, it means that I've got this as being, sorry, not the host, this as being the network. This 8 bits is for the network. This 8 bits is for the network. And remember that this is part of the network and this is part of the host. In other words, it looks like this particular IP address, 201.1.17/28, is actually on a different network than 1.14 or 1.15 or 1.2. Okay, and you can see that this happens to be host number 1 on a very different network. Okay, so it's on a completely different network. All right, now let's go off and actually try to make use of these numbers just so I can show you that this is actually working. So let me make a brand new one. Let me save this. Do you remember I got you to do a bunch of exercises, something similar to this a while ago? I think when we first started talking about the layer number 2, I asked you to pull out a bunch of computers, hook all the computers into a switch, and I got you to plug in some different values to see whether or not things would live on different networks. So give me a second here. We'll plug all of these values in, or sorry, all these computers in, so I can show you how this works. Okay, one more. Okay, and here we go. We'll fast forward the time to let those ports on block. And now what I want to do is I want to start setting up some different computer addresses. Okay, so what I'm going to do is I'm going to come in here and I'm going to pick this as 200.1.1.1. But I'm not going to use the subnet mask of 255.255.255.0, at least not yet. Okay, well, let me leave it as this is for right now, and we'll come back and we'll start making some changes. Okay, in here, we'll make this 200.1.1.2. Okay, again, I'll leave that network mask as its default for right now, but over here, I'm going to pick up the number 200.1.1.17. Okay, again, I'll leave that same network mask, and this one here, we'll set it up as 200.1.1.18. Okay, and again, I'm going to leave that as its standard mask. All right, now let's go over here, and let's try pinging the numbers. Okay, 200.1.1.18. Okay, and yes, that is working. In fact, if I ping the 255, that gives me all 3 computers responding, okay, just like what we've done before. But now I want to start really messing things up. Okay, so what I want to do is I don't want to use the number 200.1.1.1/24. Instead, I want to use 28. I want this to be 200.1.1.2/28. I want this to be 200.1.1.17/28, and I want this to be the number 201.1.18/28. Okay, so what does it mean to change this from a /24 to a /28? Well, this means I have to come in here to the subnet mask and I have to change it. Well, if you remember, I worked out the subnet mask format for this /28. It's 240 in the last octet, so I'm going to change this to 240. And guess what? I'm going to do this for all of the other computers. We'll make this 240. Okay, close this up. We'll make this also for 240. Okay, get rid of this one. And finally, we'll make this one for that's 18. This is for 240. Okay, so now that's all that I've changed. So this still has the address 1.1.1, but this time it's a /28. This is 18/28. Now, let's go into here and start trying to ping some values. Okay, first of all, let me try pinging myself. 200.1.1.1. Can I ping myself? Yes, I can. Can I ping the 0.2? Let's see. Yes, it certainly looks like I can. Now, here's the question. Can I ping the 17? Okay, well, let's give it a try. And take a look at this. Notice that this 200.1.1.17 will not work. So you might say, okay, well, maybe something is wrong. But you know what? Let me open up this one and try pinging 200.1.1.18. And guess what? I can do that, and I can also ping myself. But can I ping number 1? And the answer is no. Okay, so what gives? Okay, let's go back and let me erase all of this stuff from here down to the end again. And let's start asking some questions about 200.1.1 and the IP address 200.1.1.17. Okay, but it isn't just a /24. Now I'm talking about a /28. Okay, so let's go and write the value in binary form. Okay, so once again, 200. Now I guess I shouldn't have erased everything because it could have saved me a second. So 1100100000000100000001 and 000000001. Okay, and of course that is a /28. So we're talking a bunch of ends here, bunch of ends here, bunch of ends here, and 1, 2, 3, 4 ends right here. Okay, and then the rest of it's the host. Now let's do the same thing for this value. Okay, 200, that's, well, that looks kind of familiar, doesn't it? Okay, and finally, the number 17, if you remember, happens to look like this. Okay, and again, because this is a /28, okay, it's going to look like this. Okay, and then I've got one extra value, and I'm going to be a little bit lazy here. Let me copy and paste, and let me throw in this number right here, number 2, and we know binary format, it looks like this. Okay, so now imagine that you're sitting on computer 200.1.1.1/28. Can you ping 200.1.1.2? Yes, you can through a switch, because we'll take a look at the network part. The network part of this computer, the 1.2, is exactly the same as the network number for 1.1. But take a look at this one down here. This is on a different network, and that's the reason why I cannot reach the 17 or 18, because they are sitting on a very different network. So if I wanted to get there, what could I do? If I didn't want to change the size of the network, well, what I'd have to do is I'd have to introduce a router. Exactly the same thing as what we did before. So you introduce a router, and you'd have two separate networks, and you'd route the packets between the two. Okay, well, here, since we're here, let's try one extra thing. If we wanted to send a broadcast ping, where would we end up sending it? Okay, well, remember that a broadcast is simply something that has a bunch of ones at the end. Okay, so what we would want is, in order to broadcast, okay, 200.1.1.something, we'll fix that in a few seconds. What would we have to do? Well, we'd have to send out to this number right here a bunch of ones. Well, what number does that happen to be? Well, that happens to be the number 15/28. Okay, and that's what we end up using to get our broadcast. Okay, so let's give it a try. .15. Now, what should I see as a response? Well, I should see the 200.1.1.2. Okay, and of course that's exactly what I'm getting, but I'm not getting anybody else. Okay, so that's fine. Now, what about if I was over here and I wanted to broadcast message to all of the other computers? Well, remember, that's a completely different network. That's the network that's down here. So this is 200.1.1. I'm not sure yet, but I'll come back and fix it. Okay, so what we're talking about is the network number, the network number that ends in the 0001, and of course we're talking about this number right here. Well, to put this into decimal form, all we need to do is to figure out what this number happens to be, and well, to me that looks like the number 31. So let's pop open here and let's try pinging myself. Okay, that's fine. And if I try pinging 18, that's fine. And if I try pinging the number 31, that should be a broadcast, which means that everybody else on my same network should respond. Well, there's only one other computer, which happens to be the 18. Okay. All right. So give me a minute. I have to stop just so I can prepare for the next little part. Okay. Right back. Okay. Welcome back. Okay. So our next little piece. All right. So I've shown you the 20 slash 28. Does this mean that I can just use any set of numbers at all, like slash 2, slash 3, slash 4, slash 30? Yeah, actually I can. In fact, what I'm going to do is I'm going to show you a very useful particular set of ranges in order to solve that problem that I had before. Okay, think about this. Here's that same number again, the 200.1.1.1. This time what I'm going to do is I'm going to put a slash 30. Okay, so what does this mean for 30? Okay, well that means that my subnet mask would end up with 30 ones in it. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, and 31, 32. Okay, so the first thing is maybe we better know what these numbers happen to look like. Okay, as in decimal, which is the way that you have to record these, well, that's definitely 255, 255, 255. Okay, so what is that number? Okay, well, let's find out. Okay, this is the number 252. 252. Okay, so there we go. There's the subnet mask. All right, so let's go back over and start experimenting. In fact, what I'm going to do is I'm not even going to go through the theory. Let's just try these on these computers up here to see what we can actually get to work, and then I'll come back and explain the theory in a second. So please remember 252. All right, so I'm going to come in here and I'm going to change the subnet mask to 252. Okay, that's going to go away. That's the only thing I'm going to do. And I'll come in here and I'll change this to 252. All right, in here, I'm also going to change this to 252. Okay, and finally, I'm going to pop this one in here, and we're going to call this 252 as well. Okay, and we're going to come back in here and just do a little experiment. Okay, so once again, let's try pinging some stuff. So this time, everything is the same, except now that my subnet mask has been changed to 252. Okay, so the first question is, can I ping myself? And the answer is yes, I certainly can. Can I ping the 1.1.1.2? And yeah, that certainly works fine. And can I ping the 17? And well, kind of as expected, that's in a different spot. But this time, I want to come in here to the IP config, and I want to change this to something a little bit easier. Let's try pinging it. Let's try setting it to number 3, because that certainly seems like a reasonable value. Oh, and look at this. It doesn't like this number at all. It says it's an invalid number. Okay, well, why on earth is it an invalid number? Okay, let's go in and actually take a look at the value. Okay, so first of all, the number 200.1.1.1 slash 30, let's write this out in binary form. Oh, here I go again. I'm always erasing too many things. So here's the number 200. Okay, 1101000. So 1100100. 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. And 1, 2, 3, 4, 5, 6, 7, 8. All right, there's one number. I'm interested in, of course, this number right here. And I'm also interested in this number right here, number 3, because that seems to be giving me some problems. Okay, now luckily I don't need to do a whole lot of work. I can probably copy and paste all of these things back in again. Okay, and we can just start making a couple small changes to them. All right, now before we get down here, remember the way how this works. Slash 30, it means that I've got 1, 2, 3, 4, 5, 6, 7, 8, and that'll be 16. This will be 24, 25, 26, 27, 28, 29, 30, and these two things right here, that's the actual host number. Everything else is a network number. Now take a look at this address. Notice that this address lives on a particular network. And this one happens to live on, guess what, exactly the same network. Okay, the only difference is the host number looks like this. Now what about this number down here? Well, remember that this number looks like this. So it does live on the same network, but I hope you recognize when you have host bits are all 1. What that means is this is the broadcast address. Okay, so if you wanted to talk to everybody on the same network, you would send out a message to this number right here. So that's the reason why I got that error message a few seconds ago, because I'm not allowed to set it as the broadcast address. Oh, okay. So, in other words, on this particular network, how many computers could I have? It looks like I could have only two. I could have the .1 and the .2 because .3 happens to be a broadcast address. Okay, so let's put this away. So in other words, if I pop this open and I ask for number 3, what am I going to get? Well, I'm going to get a broadcast ping to everybody who's on the same network. Who else is on my same network? Well, there's only one other computer, which happens to be the point 2. So that can be a little bit surprising, because I'm sure you're looking at this thinking, well, wait a minute, if I ping point 3, I'm actually getting a response from point 2. Well, that's because point 3 is actually the broadcast. Okay, let's put this away and let's try the next address then. Let's try 200.1.1.4. Is that allowed? And that certainly looks like it's allowed. We'll make it 252. And, oh, sorry, did I, 252? Did I just mistype something? Oh, it didn't like the point 4. Okay, what's wrong with point 4? Well, let's take a look at the actual value, 200.1.1/30. Okay, this will be 11001000. Okay, there's ones and zeros, and this happens to be the number that looks like this. Once again, let's mark down the network part and the host part. Okay, there we go. There's the host part. Now, notice the host number. The host number is 0. Are you allowed to have a host number of 0? I'm hoping you remember you're not allowed to have that, because that's called the network number. Okay, so when you have host numbers all being 0 bits, you're not allowed to use it. So in other words, I can't use this particular value. So what I would have to do is, the computer that I could probably finally get away with using is going to end up being something that looks like this, or in other words, 0.5. Okay, let's see. Does that finally let me set my value? Sorry, wrong computer. Let's try 0.5 and 252. Okay, good. All right, and since we're here, okay, so I suppose I should be changing these so that I'm not confused later. Okay, let's call that number 5. And, well, what do you think the next value I'm going to pick? Well, I'm going to pick a number 6, not 16, number 6. Okay, and over here, I'm going to change this to be /30. I'm going to change this to be /30 so that my labels happen to match. Okay, so let's come in here, double check. Okay, that's a 5, /30. This one in here, we'll also set to 6/30. And it says it's already in use. Did I mistype something? 200.1.1.6.252. Okay, there we go. I think I hit a 5 by accident. Okay, so now pop this open again, and once again do a little bit of pinging. Okay, 200.1.1.2. Yes, I get that. Number 3 happens to be a broadcast on my network. Can I ping number 5? And the answer is no, I can't, because, well, guess what? It's a different network number. Okay, now let's go over here and let's open up this one and see if we can ping 1.5. And yes, I can ping 1.5. Can I ping 1.6? Yeah, because it happens to be the next value. And what about number 7? Okay, when I ping number 7, notice I'm getting back responses from point 6. Okay, what's happening here? Well, once again, just like what I've done a pile of other times, let's make a copy of this, paste it here, and I want to take a look at the values for 6, and I want to take a look at the values for 7. Okay, number 6 is this number right here, and number 7 looks like this. Okay, remember, these are the host names. It's only 2 bits for the host. So this is a valid host, this is a valid host, 00 means it's the network number, and 11 means it's the broadcast. So take a look at this. When you have a /30 network, how many hosts can you have on each of the networks? Well, you can actually only have 2. Oh, well, think about this. Let's go back over to my... Okay, just let me a second. Save this. And let me open up my little mini world that I had a second ago. Yes, I want to save that. Okay, so remember what I did last time is I used the entire 200.1.1.1/24 network. In other words, I lost a whole pile of addresses to things. Maybe a better option would be to use /30. Okay, which means I could also use /30 here. So how many values can I not use? Well, I can't use the /0 and I can't use the /3 because that's the network and the host. But over here, rather than using 200.1.2, I could come here and I could say, well, let's use the number 5, okay, 1.6, but not, of course, /24, but I'm talking /30. And over here, also /30. Well, could we just continue on and use /30s for other things? Sure. Now, let's see if you can figure this out. So remember, I could use 1 and 2. I had to skip 3 and 4. I could use 5 and 6, and guess what I have to skip? I have to skip number 7 because that happens to be the broadcast address for this link. 8 would be the network name in the next part, but I could certainly use 9. Okay, and what would I use at this end? Probably number 10. Okay, but now you see the whole advantage of this is I'm only using this 200.1.1. In fact, how many of these things can I get away with? Well, actually, it turns out there's quite a few. So everything that begins with 200.1.1. Well, I've got a whole bunch of bits in here. I actually have a whole lot of different networks. Each network has, of course, a limited number of hosts. All right, and you saw me save that as a few seconds ago under the name classless. So if you remember in a couple of classes ago, I talked about Class A networks, Class B networks, and Class C networks, and I said later I will come back and talk about something called classless networks. That's exactly what these are. The word classful network simply means that these slash numbers are /8, /16, or /24, and when we're talking about classless IP addresses, well, basically it's all the other possibilities. Okay, the only thing that's a little bit funny, in case you really want to go and try this, it's going to be a little bit of work. If you want to try setting it up, it is possible. It's not part of this course, so if you say, no, I just don't want to do it, it's completely fine. You can ignore this. Okay, if you want to set up this address on this one, okay, first of all, I'd have to find out what interface this is, so that's FA00. If you really want to try it, just to give you an idea, this is called enabling configuration, and I'd like to run a configuration from the terminal. Okay, and I would like to set up the interface called FA00, and what I want to do is I want to give it the IP address. So you say IP address 200/112, and the network mask is 255.255.252. Okay, that's actually how you go about this. And you also have to say no shutdown, and that's actually what will bring the link into an upstate. Okay, and this will end up looking after the routing. Unfortunately, if you there's actually one other thing that you have to do. Let me type the word exit. You'd also have to say IP route, and you'd have to say, I'm sorry, I can't actually remember what I have to put in here. Give me a second. I can cheat a little tiny bit. Router rip. Okay, this is what I need, a router rip. And the thing that you have to do is you have to turn it on to version 2. Okay, so unfortunately it requires a little bit of configuration by hand, and then you have to start adding rip routes to things. Okay, so I'm not going to go through this one, but suffice to say, it is possible to configure these, but it just can't happen through this interface over here. You actually have to learn some router command things. So if you want to, you can do a little bit of searching on the internet and try it, but don't worry, you don't actually have to go off and do this. Okay, come back. I'm going to stop this video because I think it's probably long enough, and I've got a second problem that I also want to solve. Then I'm going to leave some exercises for you. Okay?